Yes, hello student. Today I am going to discuss one more example of greedy approach, that is traveling salesman problem. First of all, what is traveling salesman problem? Traveling salesman problem is the one of the very common problem in which there is a postman who has to deliver n number of letters in n number of cities, so that he require minimum amount, he required to travel minimum distance to post all the letters to all the cities. I am repeating it once again. Suppose there are n cities and there is a postman who has letters from for all the cities, and he has to deliver all the letters to all the cities. Then what will be the minimum distance that he has to travel to deliver all the packets to the all possible destinations? This is what this problem is called the traveling salesman problem. This same problem will come in when you will study the dynamic programming and branch and bound technique also. But right now I am discussing the greedy approach to solve the traveling salesman problem. And so we have to cover all the cities, and while covering all the cities, we have to maintain the minimum distance that will be traveled by the postman to deliver all the letters. So this is a very simple question. I shall start with a simple example in which I should draw a diagram with n number of cities, and which I shall explain you how we can solve this problem using the greedy approach. So the question, there is a graph, and first I provide the graph. So suppose there are 8 cities, H1, H2 up to H8, these node represents the cities, and our postman has to travel, salesman has to travel these 8 cities, and he has to travel all the cities, so that he travels a single city a single time, and he travel after covering all the cities, he travels the minimum distance. So here what we have to do, we have to pass through each city but only once, and while doing this we should cover minimum distance. This is called the greedy approach. So for solving this problem, what we shall do, we shall create a matrix where there will be H1, H2, H3, H4, H5, H6, H7, and H8. Similarly, to the column, we shall draw a number of columns: H1, H2, H3, H4, Here I shall draw the edge matrix or weight matrix for this graph. Here from h1 to this is the undirected graph. So from the h1, distance of h1 is 0, h2 is 5 at distance 5, and h3 is not connected. I am writing the direct distance between the two nodes. So h1 to h3 is not connected directly. So there are infinite distance. Here, if a node is not directly connected, then the distance is represented by the infinity. After that, distance of h1 with h4 is equals to 6. Similarly, h5 is not connected, and h6 is the distance 4. h7 is not connected, and h8 is at distance 7. Right? Similarly, I am drawing the distance matrix for this graph. h2 to h1 is 5. h2 to h0, h3 is 3 to h2, h4 is 4, h2 to h5 is 3, h2 to h6 not connected, h2 to h7 not connected, h2 to h8 not connected, h3. h3 is connected only to two nodes. H2 is distance of h3 at distance of 2, and h3 is connected to h4 1, and rest of the nodes are not connected. Right? It is connected with only two nodes, so I have just filled these two values, and after that I shall fill rest of the places with infinity symbol. Infinity means they are not directly connected. H4 is connected to three nodes. H4 is connected to H1 by distance 6, to H2 by distance of 4, then H3 by distance of 1, and rest of the nodes are not directly. Right? And the rest of the nodes are not directly connected. H2 and H1 are after that H5. H5 is connected to H2, H2 by distance of 3, to H7 by distance of 6, and H8 by distance of 4. And the rest of the nodes are at infinite distance. Right? After this, we shall consider the H6 node. This is connected with H1 by distance of 4, and H7 by distance of 3. And the rest of the nodes are at infinite distance. Right? H7 is connected to H6 by distance of 3. H5 by distance of 6, and H8 by distance of 2, and the rest of the nodes are infinite. Right? Now, the last node is H8 is connected to H7 by distance of 2, and H5 by distance of 4. Okay? And H8 is not connected to H6. Here, one point, each node is connected to itself, so distance of H7 with H7 is equals to 0. Similarly, distance of H6 with H6 is equals to 0, and distance of H5 with H5 is equals to 0. Similarly, distance of H4 with H4 will be 0. Distance of H3 with H3 will be 0. H2 with H2 So I have drawn the weight matrix for this graph. Here I have plotted a n cross n matrix for the n cities, and the entries are representing the distance between the corresponding nodes or cities. After this, we shall start a process. Among the node, we shall choose any one point which we shall start. Suppose I am starting at the point h1. Now, at that point, I shall find out what is the nearest neighbor to that node. For that, I shall check out the distance of each nodes from that point which are directly connected, and among these nodes, I shall find out the one with minimum weight. Here, the four nodes are connected 5, 6, 4, and 7. Among these, the node number H1 is connected with H6 by distance of 4. So I shall write H1 is connected to H4 by distance of 4. Right? After that, since this node is at H6, so I shall mark the node H6 here, and I shall find out the node that is connected to the H6 and that has not been covered in last steps and at minimum distance. Here H6 is connected with two nodes H1 and H7, but H1 is already covered. Whenever one node is covered, then that node is not covered again. This is the basic condition of traveling salesman problem. So among these, the 3 is minimum. So and H6 will not be chosen because the H6 is also a covered node. So we shall select this node H7 at distance 3. So I am drawing a H7 at distance of 3. Right? And our color is something H1. Right? At distance of 3. Right? So H6 has been covered. Now at distance 3 we have found the node H7. Right? Now we shall do? We shall find out the node which are connected to H7 and not covered in the last steps and have minimum weight. The connected nodes are H5, H6 and H8. Among these, 2 is minimum and it has not been covered yet. So we shall cover 2 and next node is H8. H8 at distance of 2. Right? So the next node will be H8. So now we shall again find out the nodes which are connected to H8 and not in the covered node list. The nodes are H5 and H7. Among these, the node H7 is at the minimum distance. So we shall cover H7. Among these nodes, H7 is already covered. Here, node number X2 is smaller than 4, but X7 is already covered node, so we shall consider H5. So we shall consider the next node, that is H5. H5 is not covered, so we shall mark at distance 4 H5. Right? H5 at node 4, distance 4 we have found a node H5. Now from H5 we shall find out that what is the next node that is closest to it. There are 3 nodes which are connected to it. The minimum one is 3 and that is H2. And H2 is not covered. H2 is not covered, so we shall mark this node. So at distance of 3 we shall mark the node H2 at distance of 3. Here H2, here we shall mark, here after marking this H5, there is no H2, H5 is also covered. Okay, now we shall repeat the same procedure from node to, we shall find out the closest node the closest node is H3 at distance 2. 0 will not be considered because it is already covered. So we shall consider at distance 2. We have covered node H3. Right? After this, through H3, we shall find out the closest node that has not been covered. So the next node is H4 is the minimum one. So we shall select at distance 1, the next node is H4. Right? After that, there is no we are left with the no nodes. There is no node that has not been covered. All the nodes has been covered, and we have found a sequence. And corresponding to this, after adding all these, we have found that the total value is equals to 4 plus 3. I am writing it just here. 4 plus 3 plus 2 plus 4 plus 3 plus 2 plus 1 is equals to 4 plus 3, 7, 8, 9, 13, 16, 17, 18, 19. So by adding all these values, we have got that 19 is the minimum distance that we have to travel to cover all the nodes in and all the cover nodes. This will be the optimal distance required that postman has to travel or the salesman has to travel to cover all the cities. This may appear that this is very simple problem, but there is a condition that for each graph we cannot find the traveling, so I cannot find always the traveling salesman problem, or TSP problem, because this depends upon the point from where we start. It is possible that the node from where we start does not give you the optimal solution. So this problem may become very complicated that we shall discuss later. But right now this is the simple approach in which we have got the solution that this is the sequence that by starting from the node H1, H4, H7, H8, H5, H2, H3 and H4, by traveling a distance of 90 meters, we can solve this problem. So that's all about the TSP.